So we finished up the first table because we took its equation, we plugged in the x's, we solved the math. We now need to go to the second table. Okay, second equation, -2 times the x. So what x are we looking at first? 0. And then it says add 15 to it, right? So we have to solve the multiplication part. What would we get? 0 plus 15. And we put the answer on the table. So what would the answer be? Remember, it's the same thing. I appreciate your help, but we need others stepping up and participating. Right now, we are not doing heavy math. We're doing basic adding and subtracting and multiplying and stuff. Use your calculators if you have to. Now, we are copying what we just got done with, right? Because we're working smart, not hard. The same process will happen for the rest of the table. It's just the parentheses is going to change up to the correct one for the problem. So I need 4 more of these. And just like we got done doing, we are going to go ahead and we're going to change the parentheses to what it should be for each of the levels. So we finished the 0 level. What is the next parentheses going to be changed to? Not a 0, but what instead? Not a 0 times -2. What instead? The 1. Yes. Then we have to go do the math. -2 times 1 does not make 0. We're changing this to what it should be. So what is that? -2 times 1. What would we change that to? Because it's not a 0 anymore. We have to do the multiplication. -2. Okay. And then we combine it with the positive 15. What's going to go in our table? What's going to go in our table? 13. Thank you. Because -2 with positive 15, they're different signs. We subtract and keep the sign of the bigger one. The bigger one was positive, so positive 13. Okay, what's our next 0 changing to? Because we're just going down the list of the table. And we're changing what we had before to what we need. So what's my 0 changing this time to? Go look where we're at on the table. What am I going to change the 0 to? Thank you. Then after the equal sign, the 0 after the equal sign has to change to what the -2 times 2 equals. What the -2 times 2 equals. So what will we change it to? -4. Then we have to do the math. The -4 with the 15 goes on to the table. What are we going to say? I should see you guys' eyes. Come on, just because I'm on Share doesn't mean I don't see you. We've talked about this. So we have to put our final answer on the table. Do the math. A -4 with a +15 would end up getting us what? Would end up getting us what? Okay, thank you. Okay, someone take over for Francia. She's done enough now. Someone else's turn. So what are we changing the 0 to on our thing? Our next X on the table. So what are we going to be changing it to? What X are we working on now? Look where we're at in the X's on the table. What X are we working on now? What X should I change the 0 to now? What X from the table are we on? AJ, what X are we on the table? So what should I change this 0 to? Okay, Christian or Marissa or Princia or someone who's paying attention. What X should we be changing this to? What should the 0 change to? 3. Yeah. Fine. The rest of you can have lower grades for participation. I'm not going to stop them from helping us move forward. -2 times 3. What do we need? Okay, and then plus the 15. What do we get? 9. Should not take an excruciating amount of time to complete the table. Okay, what is my next 0 changing to? 4. And we do the multiplication and change the 0 to -8. And then we figure out the final answer. Final Y is going to be 7. Okay. So we have our list. We've completed the table. We've shown our work. Then it says to do what? On both tables, circle the solution. So the solution gets circled in green because solutions are green, right? Make sure you've changed yourself, okay, to green. What's my solution? Where do I see that? Okay, I notice both tables have 39. So I'm going to circle, not line, sorry, circle 39 on both tables. And then I'm going to list that as a solution, and solutions are coordinates. So again, we're agreeing because we're a solution. What coordinate does that represent? 3, 9. Okay. So we've completed the table. We've shown our work. We've circled our solution on both the tables. We've listed the solution. Now we just have to explain what that solution means. When we have that solution, what does that mean? The solution, 3, 9, what does it mean? Means, what does it mean? What is happening at that point? What's going on? If I see both numbers on the tables that are the same, what's going on? Because we're about ready to go graph it. So what is it going to look like? What's going on? Both lines intersect at that point. The lines will intersect. That's the fancy math word. The not fancy math word is cross. At that point, because. Why are they crossing at that point? What's going on that they're crossing at that point? What's going on with their two rules? What's happening between their two rules? The equations would be equal at that point. Right? That's the point of intersection. The whole idea of intersection is the fact that that's what's going to make my equations equal to each other. Right? So we've got to go get our coordinates from each of the tables. No, we are not copying and pasting into the chat. So we're going to make our tables. Okay, we're going to make our tables. And all we do for our tables is we take the X and the Y that's on the table, put it in parentheses, the comma between the numbers. So for the red one, the first one is 0, comma, -3. Right? What would my next one be? 1, comma, 1, because that's the next row down on the red one. Someone else, what would the next one be? 2, comma, 5. And we just keep going down the table, making the list. Make sure they're in parentheses because that's what tells us they're coordinates, not two numbers. Okay. Well, what's next? Keep going. Let's finish up the rest. 3, comma, 9. And then the last one for red would be what? 4, comma, 13. Then we have to repeat the process for the blue. Did we use different X's for the blue? No. So can't I copy this list that I just did and make a new one in blue and then just tweak it? Yeah, exactly. We're going to go copy the list we already had, copy and paste, change it to blue. And then instead of 0, -3, it's 0 what? 15. Instead of 1, 1, it's 1 what? Okay, we're fixing the 2 now. We're fixing the 9 now. Oh, that one's the same because that was the point of intersection, right? And then we're fixing the 13. So we're working smart, not hard. We're copying and pasting where we can. So then we just have to tweak and adjust. Okay. So we need these lists down below so we can graph them. So I'm going to make a copy and I'm going to put it about here. There's the blue ones. And I'm going to copy the red list. And put it with it. Because I'm going to have to scroll up on the page. Okay. So we have our graph paper given to us. Did they number the graph paper for us? No. So since they didn't number the graph paper for us, we have to figure out the scale we need. And sometimes that means that each line is going to be worth 2. And sometimes that means that each line is worth 1 or 4 and we learned about scale a couple chapters ago when we started graphing. So looking at all the points, red and blue at the same time, what is our largest Y? Look at the reds and the blues. What is the largest Y? 15. So then we've got to go see how many lines for the Y, which is the up and down, right? How many lines for the Y are available to use? How many lines for the Y are available to use? So start at the center and count up how many lines are available. And we could do it the old-fashioned way if we have to, right? Draw the lines in as we go. 1, 2, all the way up to just below the arrow. Now, is it always the case that every line is worth 1? For all graphs, every line is worth 1. Yeah, there's 17. Now, is the number 17 bigger than our largest Y? Yes, so we're happy because we get to go by ones. But what if our largest Y was 20? Could I fit by ones if our Y was 20? No. We would have to go ahead and choose a different number for the lines. Okay, so it wouldn't be 1 for each line. It might be 2, might be 3, but in this case, we get to use every line, 17. Now, working smart, not hard. I just made those lines and they're on the graph lines, right? So I am going to go, instead of having to redraw them for the bottom, I'm going to copy and paste them down to the bottom by going to my select and my little box, and I'm highlighting the lines that I drew in. I'm hitting copy and then paste. And then I'm going to take this little box down and line it up for the bottom. And I'm off. You got to make sure I start one. That way I'm getting the lines in, but I don't have to write it twice. Now, what am I going to say at the bottom of this for how many Y's I have? So yes, there's going to be times where you have to go by 2s or 3s or 4s or even 5s, maybe even 10s. It's going to depend on your biggest Y and your biggest X and your smallest Y and your smallest X. They have to fit. So how many lines do we draw in? What am I saying down here for the Y's? If I'm down for the Y's, what am I going to say? -17, exactly. Okay, because I went down, that's negative, and up is positive. Okay, so now we have to look at the x's. What's the biggest x that we have to work with? 4. What's the smallest x we have to work with? 0. Okay, how many lines do we have that we can work with? If I go to just before the arrow, how many lines do I have to work with? 11. Okay, is that larger than our biggest x? Yes. So we're going by ones in this direction as well. But this is the x direction. Left, right is x, up and down is y. Now, we look. Our smallest x was how much? Our smallest x was how much? Right? How much was the smallest x? 0. So that'll definitely fit, right? What are we going to put over here on the side for how much our x's are worth? If we go negative, what do the x's, what are those worth? Negative 11. But there's going to be times when the x has to go by 2's and the y's has to go by 2's because of how the numbers fit. All right, so we've got to go graph them. I'm graphing the red one first. Make sure you're using the draw tool and a 4 because it makes it so the dot works out nice. Okay, this says I'm starting at 0 and going to -3. Which direction is -3 on our graph? Which way is -3 on our graph? Down. So I'm going to start at the center with the red and go down 3. 1, 2, 3. And boop, there's my first dot. The next one says +1, +1. So +1 over, +1 up. The next one says +2, 5. Well, I'm at +1, 1. So 2 is right next to it. And 5 would be 4 up from that. So you don't have to keep going straight up from the line that's at the bottom for the x. Just use where you're at and move in the direction. I have to go 1 more over. That's 3. 9 is 4 more up. 1, 2, 3, 4. Right? 1 more over. 4. Up 4 more. 1, 2, 3, 4. Because 13 is up 4. Okay. So we have to go connect these with our line. Connect these with our line. Now, remember what we did? We went over 1 and up 4, right? 1, 2, 3, 4. So I'm actually going to start at that next spot. Yes, it's not on my table of values, but I can find it so I can get closer to the edge of the graph paper. Okay, so you're going to go the next one up, but don't put a dot. You don't have to worry about putting a dot because we only had to worry about the dots from our table. Okay, and I'm copying and pasting the coordinates from our list next to its dot. I don't think I got the copying. That's why we made the list, so we could label. Now, the other thing I do like to do, and it is a personal preference, but for some people it helps a lot actually, is you do the fill of blank because then look, it makes the coordinates stand out. Okay. Okay, next one. I have to label my spot that was 1, 1. Okay. It doesn't have to be perfectly next to it. It just has to be near it so people could understand what it is. Okay, I'm gonna go do my next one. 2, 5. I'm just copying and pasting. Nothing special. Now, what did we say 3, 9 was? What's 3, 9 actually? What did we say the location 3, 9 was? Up above. 3, 9 stood for what? The point of intersection, the solution. So I'm going to change that to a green because I know it's my solution, right? I know that that dot is going to end up being our point of intersection. So I'm going to change my dot to green as well because it's my solution. Okay, and then I just have one more to copy over from the red, and I get to do the blue. And I get to do the blue. So we've done lots and lots of graphs. All right. So this should not feel too crazy out there like you've never done it before, because you should have by now if you're doing your assignments and you're doing your notes. You should have had a little practice at it. Okay, let's go get our blue ones. Change my dots to blue. First one says 0, 15. Well, 15 is positive, and so we have to go up. I know the top is 17, so 15 must be 2 down for that. 17, 16, 15. And I'm going to do the same thing I did before. I noticed I need to be 2 less and 1 more to the right. So down 1, down 2, right 1, right 1, down 2. Right 1, down 2 is my solution, so I don't need to draw that one again. And then 4, 7. Right 1, down 2. Because that's what I noticed was happening. The X was going up by 1, the Y was coming down by 2. This is my blue line. Okay. Up by 2, right by 1. So I can draw in my line. And we should make the line go all the way to the edge. Okay. And we have to copy and paste our blue coordinates onto the graph. Anybody not understanding the process? Oops, I forgot to change this one back to blue. Anybody having a hard time with process? That means you don't understand how to even do the work. Okay. So I'm just copying and pasting my coordinates over onto my graph. The process we just did is what you're going to be doing for yourself after class for number 2. Okay, but I am going to get started with one thing related to it. And I will explain in a moment once I get my copy and paste. So you want your coordinates close to the dot if you can. Doesn't have to be perfect, just needs to be closer so the person can understand what's going on. My last one, because I don't have to do the point of intersection, I already did it. did our graph confirm our calculation that we did in part A? Did the graph confirm the calculations from part A? Yeah, okay. So you're going to repeat the same process, and you're going to do number 2 on your own outside of class. Couple things. We're going to work on. Who sees that there's a problem? I see there's a problem. Something's not formatted correctly. What is not formatted correctly? The first one is not coordinate. It's not formatted the way it should be. What should we have? What should our format be all the time? Y equals mx plus b. Okay. So this first equation, this blue equation, is not in the correct format, right? So we need to adjust it. We need to fix it so it is in the right format. What would be the correct way to say this? Yeah. Plus 7. Is there a positive sign in front of that 7? No. So 3x minus 7. Okay. And you would do the same process we did to calculate the table. The other thing that happened is, for some reason, when it was copied and pasted, they left off the word solution. So we're going to put that in black because there should have been the word solution here with a blank to fill in. Okay. So when you go fill that in, use the equation and you'll be able to set it on top of it. Okay. So they forgot to put the equation, the solution line. Okay. But everything else is going to be the same. The other thing they didn't do is they didn't give you the x's. They did not give you the x's. I am going to give you the x's that we worked on in period 2. You are then going to use those x's to complete the table. Not right now. Not right now. The deadline's going to be 6 o'clock tonight, so you'll have time, because I want to get on to and working on numbers 3 and 4. Okay. The process for 2 is not different. So the x's you're going to be using, we're getting our blue numbers. -4, -2, 0, +1, +3, and +5. Now, the reason why we pick these ones, when you're choosing for yourself coordinates in order to solve for the point of intersection, you cannot always use -1, -2, 0, 1, 2, because that will not always find your point of intersection. Case in point, on this first one, 3 was our x solution. That would not have been in the -1, -2, 0, 1, 2, right? Because that's 3. Okay, so that's 3. So when you're going and you're having to pick for yourself x's to choose, you need to choose 2 negatives. Okay. You need to choose 0, always 0, because we need to know the start point. And then you have to have 3 positives. Now, I picked some that were evens and some that were odds on purpose. Okay, some evens and some odds, 2 negatives, 0, 3 positives. Okay, because you will have one on your homework that you have to go ahead and for yourself pick X values. All right. So you're always picking 2 negatives, 0, and 3 positives. Pick some that are odds, pick some that are evens. Okay. We're going to copy and paste these blue ones over to the red zone. Okay, so I'm just going to go and do my select, copy, paste. We then move it to where we need it, right? And we change its color. All right, and then you do the math just like we did up in number 1. All right, but that's going to be after class, not right now. We're going to move down to number 3. Because many of you, when you were doing your assignment 2 days ago, you didn't bother to read instructions. Okay, you didn't bother to read instructions, so you did the worksheet incorrectly. Okay. We learned how to do this equal values method, EVM. We learned how to do this equal value method, but then everybody got their heads stuck on graphing and tables. And they wasted a whole bunch of time 2 days ago on the second part of their homework because they didn't bother to read the instructions. So you're not going to get full credit if you're not following instructions. All right. So equal value method means exactly that. We're setting the equations equal. We're setting the equations equal. So we have a 3x plus 5 that's going to equal a 4x plus 8. And we're going to do our big zeros and big ones and figure out what x it is. And then we're going to plug it back in to figure out the y. We did these multiple times. But people didn't read the instructions 2 days ago, so they got partial credit for that homework. Okay, so we are going to do some big zeros and big ones. What do we move first? We need to be solving for this x. We move letters. Which letter are we going to move first? What kind of letters move first? So we're looking at our letters. How do we move our letters? How do we choose which letter to move? How do we choose which letter to move? Well, how do we make a decision which letter we're going to move to who? What do we do? What do we look for? Smallest moves. Okay, so we need to move the smallest one. How are we going to go about moving the smallest one? We need to turn it into a big zero. How are we going to turn that positive 3x into a 0? Yep, subtract 3x on both sides. So minus 3x. Whatever we do on the left, we have to do on the right. We have to keep the balance, right? We have to keep the balance. So 3x minus 3x all gone, right? Do the math. What's going to be left on the left-hand side then? 5, all right? And that 5, which is all that's left, is going to be equal to what happens on the right-hand side? X plus 8. Well, why is it just x? Why isn't there a number anymore? Where did the number go? Yes, it's a trick question. Where'd the number go? What's the number really? A 1, and a 1 doesn't matter, yes. So technically, 4x's minus 3x's, that's 1x, right? But we don't list that 1 in front because 1 times, that doesn't change anything. It doesn't change anything. So we don't bother writing 1x. We just write x. Okay. Are the big zeros and big ones done? Have we handled all the addition and subtraction yet? No. So what needs to move and how are we moving it? We need to move away from the letters. So what needs to move? We need this positive 8 to move. And to make it positive 8 turn into 0, because that's how we move with addition and subtraction, we turn it into 0. We're going to subtract 8 from both sides. So 8 from the left. Whatever we do on the left, we have to line it up and do on the right. That made the big 0. So that's gone. The 8's gone. And since there's no number in front of the x that would make any difference, there is a number, 1, but it's not going to make a difference. We are done solving for x. What is the value of x going to be? When they're in balance, what's the value of x going to be? X is going to be -3 because 5 take away 8 is -3. So if they're in balance, the x would be -3. So now we have to go figure out what the y is going to be when they're in balance. And to do that, we're using the 2 equations. One of them for the check and one of them for solving for y. So our first one, we need to have a solve for y. And we also need to have a check. You have to do both. So one of the equations is going to be used to solve for y, and one of the equations is going to be used to check. Does it matter which one we choose to solve and which one we choose for check? No, it matters not, but you have to use them both. Okay, so which do we want to pick for our check? And which do we want to pick for our solve for y? It does not matter who is who. We just need to use one for solve for y and the other one for the check. Okay, so the 3x plus 5, we're going to solve for y. Okay, so we're going to say y equals 3x plus 5. That's going to be my check. That's going to be my solve for y. Okay, and then for the check, I'm using the other one. And check is checking a solution. I get to change to green. And that's going to be y equals 4x plus 8. Okay, so one of the original equations gets used to solve for y. The other one gets used to check the solution. So that's why I just turned it green. We're checking the solution. Okay, in this solve for y, we're going to use this x we just figured out. So instead of having an x now, we're going to say that our x equals -3. So 3 parentheses, 3 plus 5. So we're substituting in, we're replacing the x from the one we chose to solve for y with by the x that we found. Okay. Now it's just like the table of values. Do the math for the multiplication. What are we going to get? -9. And then get us a final answer for the y. Y equals -4. And now we have to write the solution and solutions in green. Okay. So we're looking at our solution. What would we have? What would our coordinates be of the solution then that made them equal? What was the x we found? What was the y we found? That was the point of why we did it. The X was when they were in balance and the Y. So -3, -4. That's what we believe the solution is. But we're going to go check it. We're going to go do the check. So to do the check, we're taking the X we found. We're taking the Y we found. We are putting it into the second equation. And we're going to see if they balance so we could do the check mark. We checked it. Okay. So we said in the solution that our Y should be -4. And if we're in balance, and that means that 4 times -3 plus 8 should equal that -4. If we did everything correctly, that should be happening. Okay. So left side's not changing. Right side's the one that's changing. Right side, we're doing math. 4 times -3, 12. And then we're supposed to add 8 to it. And if we take a -12 and we add 8 to it, what do we get? -4, which is good news because now we can say it checked out, right? Oops, -4 equals -4. So we are in the happy mode because it checked out. If it didn't check out, you need to go back and look at some of your work because maybe you added when you should have been subtracting, or you added when you should have been multiplying. I can tell you during high stress situations, during tests and stuff, I have seen plenty of students say 2 times 3 is 5. So if it doesn't check out, that's because you've done a math error in the solve for X or in the solve for Y. So maybe when you went to go do this -9 plus 5, you accidentally said +4. That would throw off your check. Okay, that kind of stuff. Okay, so that's the equal value method. Questions about that? We did that process before, but when the people saw that instructions, they didn't do those instructions on that homework assignment and got partial credit. So, any questions about that? Because remember, that's the whole point of intersection. It's when they're equal. Okay. So we are still doing equal value method, but now it's a word problem. So we have to set the equations up for ourselves. And we have to have a sentence answer because it's a word problem. Okay. So we're going to make our little table of things. First thing we have to decide is our labels. I have J for Janelle. I don't feel like typing out her whole name. If you want to type her whole name, be my guest. I have A for April, right? That's the two situations going on. Janelle's situation and April's situation, right? Now they're telling us in the story some beginning. What letter from the equation is the beginning? The start value. Let's say start value here. Okay. The start value is our B, right? They also have to tell you in the story in order for it to work. They have to tell you growth. What letter from our format is the growth? N. Okay. So we are going to be creating from that information our equation. And our equation is supposed to look like what? Y equals mx plus b. Okay, so now that we've got our little table set up, we're going to pull information out of the story onto the table to create the equations. Okay. So according to the story, what was Janelle's start value? $20. Janelle has $20. Must be where she started, right? According to the story, how much is Janelle going to make her money grow? +$6 And this is positive $20 each week. Make sure you're doing your signs right now because it'll matter in case you've got a shrinking and one's stretching. So if I was going to pull that information together into an equation, what would I say? Y equals 6x plus 20. Exactly. Okay, so now we're going to go repeat the process for April. Okay. April's blue. I have to change to number too. Let me fix that. This should have been a red. Remember, we got two situations. Okay, so what is it saying April's start value is? Yeah, ooh, she has a lot. Positive 150. From the story, what does it say April's growth is? Positive $4 each week. Yes. So that means that her equation would be what? Y equals 4x plus 150. So it asked us in the instructions to find the equations, and we did. Okay. Then it says in part B, using those equations with the equal value method, solve. Remember to write your answer as a sentence. So what am I going to do with these two equations if I'm using equal value method? What am I going to do? What's it going to say? If I'm going to try and find the equal point, what am I going to say? Yes, we're going to say that the first equation, 6x plus 20, is going to equal the second equation, 4x plus 150. Okay. And just like we did in question 3, we're going to solve. We're going to do our big zeros and our big ones. Okay. So put my balance beam in. Oops, it's still the circle, but this will work. Okay. Who am I going to move? How am I going to move it? I'm going to subtract 4x from either side because I know I have to move the letters first and I have to move the smallest letter. And the smallest letter is a 4x. So I have to do the opposite of positive 4x. So I have to subtract 4x from both sides of the balance, the equal sign. Right? And then I do the math to figure out what's left. My 4x is gone. What's the left side going to say? Do the math. 2x plus 20. And we're staying in balance, so it has to equal what was left on the left-hand side, 150. Okay. Have I handled all my adding and subtracting? No. What needs to go? The positive 20, exactly. How am I going to make that positive 20 go? Subtract 20 from both sides. Whatever we do on the left, we repeat on the right. Whatever we do on the right, we repeat on the left. Okay? So it doesn't matter which side it's moving from. We just have to make sure we stay in balance. Okay. So 20 take away 20, all gone. Do the math. What's left on the left-hand side then? Two x. and it has to equal, because we're in balance, what's going on the right-hand side? 130. Okay. Have we handled all of the adding and subtracting now? So now we have to get the letter completely alone by doing the big one. So we have to look at what numbers with the letter. I see a 2. I need to undo the relationship. When a letter is stuck to a number, what's the relationship? What math operation is doing when we stick a letter to a number? Multiplying. So we have to undo multiply. We have to undo multiply. So we're going to divide by whatever's with the x. We have to undo whatever's with the x. It's multiplied by 2. So we're going to need to divide both sides by 2 because we need to make that multiply by 2 go away. So 2x, and then I have it divided by 2, arrow off it, has to equal my 130 divided by 2. Right? 2 divided by 2 is 1, and we know 1 times doesn't matter. So our x has to equal what? We need a unit of measure because this is a word problem. What is our x standing for? 65 what? Look at the story. What did it say the x stood for? What did it say the x stood for? Read the story. It tells you. Let x represent what? Let x represent what? Read up above. If I'm not saying yes to the answer, that must mean that the answer is not correct. Go look in the words. Weeks, not money. So now we have to do like we did up above. One of the equations is going to be our solve for y. And one of our equations is going to be our check. Does it matter which is which? No. So I'm going to put the solve for y at 4x plus 150. Y equals 4x plus 150. And I'm going to use the other one for the check, which is the solution. So I'm going to use the y equals 6x plus 20 for my check solution. Did it matter? No. We're just working. Okay, we're taking the x we just found and putting it into the equation. Okay. Now we're solving for y. What is the y standing for? We'll read the words up above. What is the y standing for? If the x stood for weeks. What's the y standing for? The x standing for weeks. It must be the money, exactly. Okay, so go do the multiplication. Use your calculator. 4 times 65, we're finding the money now. We found out how many weeks it would take for them to be equal. Now we're going to figure out how much money it is at that point. Okay, 260 plus the 150 that we already have. What are we going to get? But what's my unit of measure? What I'm going to say my unit of measure is money. So what am I going to put to show this is money? The money symbol. And to do the money symbol, you have to tap twice. That's what I found out. Okay. So when you push the money symbol the first time, it won't show up. You have to tap it twice. Okay. So we need to answer our question and then check our solution. It will take 65 weeks for Janelle and April to have the same amount of money. And that's $410, right? Oh, that's an E right here. Your answer has to be a sentence because this is a word problem. And then we have to go finish up our check by putting in both and making sure that it checks out. So 410 has to equal 6 times 65 plus 20. We're checking if it works out. Now, what happens if it doesn't work out? We made a math error, right? We might have added incorrectly or subtracted incorrectly or multiplied or whatever. What is 6 times 65, please? 390. Okay. And if we add the 20 to the 390, what do we get? Happiness, right? We get to say check. It worked out. Okay. So on your homework, you have 2 that are graphs. Okay. You have 3 that are equal value method, and you have 1 word problem. All right. So on your worksheet for homework, you have 2 graphs like number 1 and 2. So do not forget that before 6 o'clock, you're going to need to finish number 2, like we did number 1. So altogether, you're going to be practicing 3 graphs. All right. I'm attaching the worksheet right now because for some reason it did not attach earlier. So you're going to need to refresh your homework assignment in a little bit because the worksheet didn't attach correctly. Did I say leave? I don't think so. Okay. So before 6, you need to finish number 2 on the notes, just like we did number 1. I can tell you the scale is not by ones. Okay. And then for homework, you have 2 more graphs. You have 3 of the equal value, which is question number 3, and 1 of the word problems. So it's not too bad. There's only 6 altogether. All right. So notes before 6. I'm hoping that it'll let me process the video sooner rather than later, but I don't have control over that. Okay. Have a good day. We never have tutoring on Tuesdays and Thursdays. I don't know why we keep asking the same question. I had tutoring yesterday, but it had to be later. No one showed up. You guys can go.